All right, my friends, we are going to do a classic problem in statics, which is finding the tension in some cords that are hanging an object. So what we're supposed to do is find the tension in each of these two cables that are supporting this sign for a flower shop. So to get started, what you need to do for sure is draw forces. And so let's go. Well, one force is this rope on the left pulling up. We are going to creatively call that tension 1. And another force is from the rope on the right, and we are going to call that one tension 2. Now those ropes are having to struggle or are under tension because, first of all, they're pulling against each other, but they're also fighting the weight of this sign. And so the weight you can always calculate from multiplying the mass times acceleration due to gravity, which we're going to use as 10, as is done on things like AP exams. So G will be 10. And the mass of the sign happens to be 10 as well. So the next little move, or what you're going to want to do next, is decide sort of which way your positive and negative directions are, or in other words, to choose some sort of axes. And so we're just going to put our y and x axes in the standard direction here. You actually could put them in any direction you wanted, so long as you did the calculations right, but we're going to orient them like this. So our first move is going to be to apply Newton's second law, F equals ma, in the horizontal direction. So what we have to do for the left side of F equals ma, we have to look for horizontal forces. Well, the horizontal forces would be provided by the horizontal components of the tensions. Well, so here is the horizontal component of tension 1, and here is the horizontal component of tension 2. So those two horizontal forces are going to fight against each other and actually need to cancel out. All right? And so what we'll do is we'll say, well, that force going to the left, this one, is T1 cosine 70. Now, why cosine? Here's a 70-degree angle. Here's tension 1 going at it up this way. If you wanted to find the side of a little right triangle that was oriented such that the vertical leg would be here and the horizontal leg would be here, the horizontal leg would be adjacent to the 70-degree angle. You could also see the 70-degree angle right here where I'm wiggling this mouse. They're called alternate interior angles. So this right here would also be 70. So this is T1 cosine 70. Likewise, the other one going to the right would be T2 cosine 35. Well, so to sum these forces up, we'd have T2 cosine 35 going in the positive x direction, and T1 cosine 70 going in the negative x direction. Well, those forces need to add to 0 because the sign should not be accelerating to the right or left. So the forces just balance. Really, we just learned that T2 cos 35 is equal to T1 cos 70. Well, these two things are unknown. So right now we have one equation for two unknowns. So we don't really have enough information to finish because T2 is unknown and T1 is unknown in this equation. So we need a little more information. Well, we haven't really looked at the vertical direction yet. So let's look vertically. Vertically, there's going to be three forces. There are the two vertical parts of tension. So there's one and there's the other. But then we also have the weight, mg down. So those three blue arrows should balance each other out or add to 0. And so looking vertically, we have T1 sine 70 is up. It's sine because it's opposite to the 70-degree angle. T2 sine 35 is up, also opposite the 35-degree angle. And mg down. So you have T1 sine 70 up, T2 sine 35 up, and mg down, and those have to add to 0 since the sign's not accelerating. Well, so now we have two equations for two unknowns. So there's a few strategies for doing this. What I chose to do was to solve the top equation for T2 and plug it in for T2. So in other words, if I took the top equation and moved T1 cos 70 to the right and then divided by cos 35. So T2 would be T1 cos 70 divided by cos 35. And so all I've done is put that in for tension 2 here. So again, where this expression in green is coming from, that is what you get if you just solve this this equation from the horizontal forces. If you just solve it for T2 and then shove it in there for this T2. So here we are. We basically have T1 times some numbers minus 100 equals 0. Well, so if you simplify that with a calculator, what you'll find is T1 times 1.179 minus 100 equals 0. Well, that means we can solve that equation for T1. T1 would be 100 divided by 1.179, which is about 84.82. So this tension in this rope going up and to the left is 84.82 newtons. Well, now that we know that one, we can just plug into our original equation for T1 and T2 that came from the horizontal forces, and we can learn that T2 is, well, T1 times cos 70 over cos 35, as we had before. So 84.82 would be T1. But then just times these, multiplied by these trig functions, which ends up being 0.418 if you use a calculator. And you learn that T2 is 35.45 newtons. Notice that T1 came out larger. T1 is doing most of the job of supporting the weight of this thing, since it's kind of oriented a little bit more vertically. So T1 is doing most of the lifting. T2 is helping a little bit. So hopefully that helped you all. Thanks for watching, and be sure to subscribe if you'd like to learn a little bit more physics. Thanks for checking this out.